Hello, welcome back to Parapod. Today I'd like to quickly show you the uh, short session we had with Richard, Young, and I. And in the beginning, Tim spent 10 minutes with us. We're glad to see him face to face through the internet. And today I make this video to explain what we did, basically preparing for the ground, right? As you build, you need to prepare the ground. But this time we prepare the ground in a way it's better for the whole system. You don't have to do this, but if you do this, will increase the capacity, right? Increase the capacity of heat storage, right? So normally we simply use the soap liquid tank to store the energy, right? But if you build this way, it's even better. And also we in this design we incorporate the collecting of water into this whole system, so as you can see, the water will flow down, right, and then dripping, to the ground, onto the ground. But the underneath we have a rain collection system. Okay, this is something I like to explain to you quickly. So basically, as you can see, when you dig the ground, you dig 6 feet deep, and then so you have this 4 feet, to 6 feet, space where you simply put a pond liner. Okay, so the top edge of the top liner will be slightly below this, because this is the ground level for the inside, right? For this parapod for greenhouse, right? So you want the inside ground to be dry. So when you lay the pond liner, make it slightly, maybe I would say 1 feet below, or even 2 feet, depends, right? But make it slightly below the inner ground, so that once you have lots of water, right, lots of rainwater, right, then it will overflow, right? When it's overflow, then the inside will be wet, right? So for that reason, we simply when we lay the pond liner, make it lower, than the inner ground, right? So this way the overflow happens, so the water will just simply overflow to the side, right, to the soil, and you always have dry ground inside, right? So but doing this way, it's you have increased the capacity, because this is the heat sink, right? And the heat sink actually is made of gravel and water, right, only. So this way, it's neat way to do geothermal, right? This is geothermal, right? And all, we remember we have two tanks, at least two tanks beside the fish tank, right? We have two tanks, one for the fresh water, one for the soap liquid. So when I do the fresh water tank and soap liquid tank, I could even bury them, deep down, right? Even 2 feet or even 3 feet, right? So that the ground level water, the collected water in the ground, the surface will touch the bottom, even slightly above the bottom, so that we naturally have a heat exchange, right, between the soap liquid and the underground water, right? The same thing with the freshwater tank and the underground water container, right? So that way we have a passive, geothermal with a passive heat exchange, right? Yeah, and then also you can see we show that we have some drain pipe, right? So this helps with the collecting of water, and we have a space. We can create even a space in somewhere inside, so we can put the sub tank, no, sub pump, right, into that area, and so that we can by by using that sub pump, we can control the water level, right? So one way is passive, the other way is active, right? You can there's a way to decide which what the water level is. Then we can depending on our need, right? If you want more moisture, then you don't do that. If you want the inside to be dry, right, you can simply pump water out, right? And then you control the water table, water level, right? And that way, you control the humidity, right? And you control even the capacity of heat storage, right? So this is just that's why when we design the whole thing, we make it passive, as the base, but also we make it proactive, right? Depending the situation, you can control it, right? You have some kind of an easy control. It's not very hard control. It's very easy control. Yeah. So that's what it is. Yeah, very simple. And also you see the wall system, right? You see the vertical wall panels. We plan to use the whatever we're gonna use the existing system. How they make the underground the concrete wall, right? So it's kind of a foam, molded foam, right? And there's a structure, you install it, it's double layer, right? There's a cavity in between, then you pour concrete in between, right? And in this case, we don't need the concrete wall to be thick, right? Yeah, we just need some strength, right? That's enough. Because we will this time we're gonna leave the foam there, both inside and outside. We leave them there. We don't touch them, right? And that way we have better insulation, right? And so that way it's better, right? So we can, I think, I'm just guessing, right? If we do it this way, we may be able to achieve R30 or even R40, depending. I have to check, right? But basically a very thick wall system. When we did the design, we measure it. It's more than 15 inches. That wall, right? The thickness of the wall. It's a double layer with a cavity inside. It's a triple layer wall system. So that's roughly, I think it's around 15 inches, more than that. So this way we can have a very good insulation to the wall, and also very good insulation to the bottom of, remember before we see this go like this, right? We suggest use a board, but this time we use the wall system to seal everything, right? So this way, we have good insulation below this line, and then dynamic control of insulation and transparency with bubbles, right? So that's the whole idea. Yeah. So that's to explain. That's what it is. So and yeah. So basically, to sum up, the whole process will be like this. First, we're gonna dig deep, right? Like 6 feet, right down, and then we lay the pond liner, right, to a to maybe this is 6 feet, yeah, 6 feet and 4 feet, probably 3 feet, I would say. The 3 feet for the pond liner edges, right, and then that's where the overflow, is, right, and then we've just backfill with gravels, right, and then continue backfill of gravel and preparing for the inner ground, right? Let it, make sure it's flat, and then we, prepare the footings for the 4 columns, 8 columns actually, 4 columns in the center, and another 4 on the side, and then we can set up the structure, right? The structure, right? And then after the structure is set up, we can, build a wall, right? So roughly that, build a wall system, and once we finish the wall and the pouring of the concrete between the walls, it's a double layer wall system, and then we can continue backfill, right? Backfill with more gravel or some sand, right, on the surface, on the round, so that yeah, everything is compact, and the water can get filtered by the sand and then enter into the gravel area, right? Then the door will going to have a passage, going down, a way to go down a few steps. Here we shows 1, 2, 3 steps, plus the landing. There should be some space actually. This should be, because when you open the door, you have to, right? So there should be some space between the last step and the door, and that's how you enter. Double doors give you wide opening, right? So that's it. Yeah, very simple. I'm glad that Richard, yeah, adopt this, this method, of groundwater, and apparently he's been using this method a long time ago, and yeah, this is yeah, that's why we already have the geothermal built in, right? And this is one of it. This is the one of the way to increase the geothermal effect, right? Even you don't do this, you still have geothermal effect, because that's the water tank, right, inside. Yeah. But if you do this, then the geothermal effect will be even greater, right? I think this is in colder area, this is something you have to do, right? Because it's really cold, right? What if the weather is like 2 weeks, no suns, right? Cloudy for 2 weeks, and it's very cold outside, minus 30, and then the only heat source you have is during the day, right? During the day, even cloudy, you can still collect heat, right? Through the bubbles, yeah, through the even liquid film, yeah. So, but still, it may not be enough, right? In that case, we use geothermal, right, to do the magic word, and then if and to for security, for the for the sake of yeah, that even geothermal is not enough, depending on the situation, right? Then you have we have a design for accelerated heating, right? Assisted heating, simply wrapping around the pipe. There is a right the because remember there's a pump, right, pumping the water up to bubble generator, right? And then we can have some way, and there's also the flowing. See, this is collected water from the bubbles, and then will flow back, right, back to the tank. And that's where that passage, that feeding tube, plumbing, right, that pipe, we can have a way to to heat around that pipe, use some kind of mechanism, and then the accelerate assisted heating system can be built in lab way. So that's just for for the sake of safety, right? In case we need it, right? So you got to have some kind of assisted heating. So that way we can control the temperature, the humidity, right? And then even the light transmission, light taking, how much light you want to take in, right? Whether you want shade or not, no shade, right? So you basically this give you the flexibility, right, to control the environment inside. This is how we do it, right? This is the it's simple, right? It's not using sophisticated equipment, right? We don't use electricity. There's some electricity involved, but it's very little, right? To electricity to supply the fan just for a few minutes every few hours, right? And then supply the pump, same thing, just a few minutes and then stop, and you don't have to use it for 2 or 3 hours, right? So and also the sub tank, if you use it, then and also if I do the IAVS sandponics, then I need another pump, right, for the fish water, right, for pumping the fish water into the grow bed, right? So that's all the power needed, right, to make the whole system work, right? And then in the case of power blackout, or someone want to build this thing off grid, right? Then simply you need a panel, right? Just one, doesn't have to be big electric. The photovoltaic panel, solar panels, just maybe one piece, and then a battery system, right, to store the electricity collected during the day, and then you can use during the night, right? As I said, we don't use too much electricity because the whole system works. You just need the electricity just for a few minutes, and then you stop. Everything stop, right? Including the sandponic, IAVS sandponics. For IAVS sandponics, I pump water every 2 hours, right? And each time I only pump for 10 minutes only, right? That's it. So very little electricity, and then everything they will take care of by themselves. That's why this design, I think, is the best system, right? Because we fully rely on the solar thermal, also photosynthesis, right, for the plant to grow, and then together with geothermal, right? And this is so far, I think this is the simplest geothermal ever. ever. I studied geothermal, right? But I never seen this system as simple as this. So this is something I'm excited. I'm glad that today we did this. Yeah. So the cover system, there is a rope edge here, so that will wrap around. That's why we show that there is line here, right? So anyway, that's it. It's oh, there's one thing I'd like to point out, maybe even for Young, if he watched this video. So actually, the placement of the bubble generator are wrong, because in my case, other people may be okay, right? But in my case, this is the east, the door facing east. So this is south side. So I want the bubbles to come out from this side first, right? So in this design, the bubbles will come out this, from here and from here. So and there. So so need to be rotated, So basically, one bubble in the front, just above the door, and one bubble machine, bubble generator at the back, the opposite side, the north side. So basically, it's looking like this. It's something like this. If this is the south side, then you can do it this way, right? Because the fan will pull air, right? Push air inside, create the pressure, right? And so the screen, the two outlet screen is here. So and then the fan, the air push the bubbles, right, through the screen and create the bubbles, and then so the bubble fall, will just pouring out from here and then move downward, right? Because the bubbles are light, they don't fall right down to the bottom. They are stick. They're very sticky. So the air push them down. Push them down to the bottom, and then bottom flowing into this region, and then going back. Going back to the fan, right? Once the bubble was completely filled the entire cavity, then it will be drawn into the fan, and it crashed, right, and then broke two pieces. I mean, then the water coming down and flow back to the soap liquid tank, right? So that's what it is. So in this case, so if we look at this way, the door should be here, right? So that's what I mean. Okay. So hope you understand. If you don't understand, you ask questions, and I'm gonna right after this, I'm gonna add the actual design session recording. Okay. This is it. I'll see you next time.
Looks like a nice day.
Yeah, very nice. Yeah. What's the temperature here? Let's see. Oh, 1 degree.
Oh gosh,
About
we
zero.
got one of the coldest days of the winter right now. It's like minus 20
Minus
something.
20. Wow.
Yeah, wind chill. It's almost minus 30 here today.
Wow.
Weird, eh? And
Yeah.
overnight it was
See,
cold. And today it's
what I call polarity, right?
it is.
The
Yeah,
hot, warm place, warmer, right? Cold place, colder.
yeah, extremes. Yeah.
Yeah, extremes.
But anyway, they say spring is going to come early, so we're looking for it to warm up rather quickly.
Okay. Yeah, good.
Yeah, I'm looking forward to that too.
Yeah. Okay, this is the file. Yeah. Yeah, this is a file we're gonna work on. The only difference, the door will be rectangular. Okay, rectangular, and maybe copy a different file because this is for my design. But it's roughly this. Yeah, because the the wall vertical wall system, I'm gonna build myself. Tim, yeah, I just want you to build the structure, the
Yeah.
columns, right? Yeah, the metal parts, and then with that I can build the wall, and then the door, right?
Yep.
I can do that. I'm a carpenter. Um, so how do we look at the? Can we look at the inside, Yang?
Yeah.
Yeah, without the wall, without the door, without even the cover, right?
Maybe even the
Huh?
2D file is good to
This
work
is
from.
2D file. Okay,
Yeah,
okay.
because it's so well presented, all the components and
Oh yeah, maybe we just
parts
go
and everything.
over the 2D file. Yeah, I mean, right?
Okay,
Yeah,
let
and
me
there are
open it.
3D image there too that we can refer to, so
Yeah,
it's clear. I love it.
yeah.
I think what I'll do is use countersunk like cap screws,
Oh
so
yeah,
it doesn't. So it
that would
just
be ideal, Tim. That was one thing I wanted to ask you about is the hardware.
Yeah,
The just kind of like a bolt head, a countersunk. Yeah, that would be perfect.
yeah. I think well, it just so it doesn't protrude, right? So you can't
yeah.
your fabric doesn't
Yeah,
get
that's
Yes.
but
ideal. This is what I was actually wanted to talk about this morning. Some just little kind of details here, and that was one of them for sure. Yeah. One thing, Tim, is like we could make one of these bow trusses just to get a look at it, right? It's two pieces of flat bar, and the way that they're fabricated because of the length, it's like creating a bow, right? It's actually called a bow or a bow truss.
yeah,
The bow,
it creates tension. Your tension is
yeah. The straight one, right, is like the string of the bow,
yeah,
and the curving one is flexing. It's not bent, right? It's just flexing
yep,
because
that's right.
it's a flat bar, and because of the difference in the length and the precision of the holes, when you assemble it, it'll take the perfect shape, right? The arch shape, the arc of a curve of the arc, section of the arc, right? That we want.
Oh. Hmm.
And see, there's a little post in there, which is the arrow, which causes the tension. So it's a combination of that the string, the stringer flat bar length,
Hmm.
and the other one is over long, and when you position it right, it has to flex in,
Hmm.
and then you also position that little post in there. That's like the arrow in a way. So, but anyway, it is an innovation, and it's very simple to build, right? It's just two pieces of flat bark. All right.
Yes, and there's a huge amount of strength in that.
Well, that's what I'd like to check. Now, also in its application, right? The forces on this arc is only the wind force. The snow is going to slide off,
Yeah.
because of the shape and all that. We really will even like melt the snow if the snow is a
Yeah.
little sticky. We can
Yeah.
put
Use
some
warm bubbles to melt it.
yeah, a little thermal energy
Yeah.
into the cavity base, right? Which
Right.
is easy for us to do,
Mm-hmm.
and that'll slide the snow off. So really, the only forces are the wind force on the skin,
Right.
which is totally uniform, right? It's no point loads at all.
Mm-hmm.
So when you put that kind of pressure on a kind of eggshell shape, right? Really resistant.
What's that
So,
sound?
and different kind of industrial fabrics as well. Like for bags, and you'll see them used in making bags, all kinds of materials. Yeah, so that's the cover. It's very you can sew it, and it's very simple.
Tim, you look very cool, huh? Good.
I
And yeah,
I also
play drums in a rock band. So.
Oh, that's fantastic.
I see.
Wow. I love the culture.
Yeah, you need
we've got
you need
many
metal
artists
music,
in
huh?
our-
Metal music. Yeah, good.
So so the whole cover is in prefabricated in one system. It pulls down over that frame like a toque, right? Like a cap.
Yeah.
And the outer surface cover layer sits on the framing, right? And the other interior fall inward, right? So it's all one assembly when it comes, right? So it's really easy to install.
Yeah.
And it's kind of like pie shapes, right? You know, if you had a round pie, you cut it like a deep pie, right? So picture the inner crust, you know, the inner crust is like the inner sheet, right? And so those segments, we call them quad panel. They fall inwardly, right? They just fall inwardly. And then, like Aubrey was saying, along the edges of the inner skin, there's a rope edge. And those, when they tie together, they tension up and make a really like a drum tight surfaces, right? So the whole cover system is not like a regular tent where, you know, if you touch a regular tent, it'll vibrate, right? You can push it, you know, the material moves in the wind and so on. But with our system, once you install it, it's tensioned everywhere and it's like drum tight, you know, it doesn't move. And because we have air, you know, like we're creating some pressure differences when we blow the bubbles, you know, there'd be some areas go into a bit of suction.
Right.
Other areas get a little bit of pressure, and you know it would behave strangely, you know, if it wasn't like really nicely made. You know, it's just, you know, so yes, you get a strength, you get a durability because you don't get any fatigue. You know, ordinarily there's a lot of fabric is moving and that over years. You know, it makes fatigue, and material will start to, you know, crack and lose
deteriorate.
Deteriorate. So, you know, although our material is transparent, it does have UV stabilizer, and you know those inner tapes that, you know, they put a film coating, a low density coating on both sides, but the interior woven ribbon, those are high density polyethylene, so they're really strong. They're stretched, you know, so there's no like, you know, film. If you cover this with a film, right, transparent film, it'll stretch over time, right? The film is really stretchy. You know, you ever try to break a plastic bag or something and it starts to stretch, right? It gets really strong. So what they're doing is they make the polyethylene film in high density film, and then they stretch it. They slit it into ribbons, and then they pull it into tapes, and then they weave those. So it's quite a technology, you know, and it's only like about 20 years since they've been doing this.
Oh, wow.
Yeah. Oh, any tarp. You probably have a tarp. Say you have an old tarp around the house. It's likely to be this material. Just tear it and take a good look at the ribbons inside. You know, you'll see in there. It's really quite, you know, fascinating. And by the way, Canadian technology. Yeah, it is.
Something to be proud of.
Yeah. I mean, the company is owned by DuPont, but they developed this in Georgian Bay is the biggest manufacturer, you know, in Ontario, and then another company, as I say, in Montreal, also got into the same technology. Their plant is in Nova Scotia, in Truro, Nova Scotia. These are enormous plants, you know. They're basically like textile, but they're working with film and tape, so it's kind of, you know, kind of interesting.
Anyway, give me a second here.
Right?
Give me 2 seconds.
Yeah, okay.
Yeah, Jan is here.
Oh, good.
Good morning.
Yeah, so maybe you open the file. right? Or you
Yeah.
know, briefly show you open your camera so Tim can see you. Well, maybe he already. Yeah, you just you know this is the first
Okay.
time, right? Yeah, this is
Yeah.
Young, our in-house
Hello.
designers. Okay.
Hey, Young.
Hello.
Yeah, that's Tim. So you are in the backyard, right?
No, I'm actually at my shop, and I
Oh, I
have
see.
I have another
Okay.
meeting at 8 o'clock.
Yeah,
Oh
sure.
yeah,
Okay.
in the car now.
Yeah.
But,
Oh, okay.
uh-oh.
Yeah, make sure you
I think
have enough battery, huh?
Yeah. Just give me 2 seconds. My neighbor's here.
Sure.
Yeah, yeah.
so. With the shelving, were you? So we just make a standard shelf, and then you have like pots or whatever that you sit on them, or
Yeah.
The shelf, yeah, I plan to have only 2 layers, you know, instead of 3, because
Oh,
you know, I just want to make it simple, right?
yeah, yeah, yeah.
Yeah. Just I want to have some room, right? So I have my computer, you know, some equipment there, you know, do the testing,
Sure,
right?
sure.
Yeah,
I like the idea. Don't go overboard, Jim.
yeah. I don't want to
Yeah.
make it cloudy, and then how do you present it, right?
And then you'll have a good amount of space over the tanks to look after the fish.
Yes, that's right. Yeah.
Able to reach everything and
Yeah,
make
that's right. I like to have more room between the first shelf, right? First shelving, you know, some separation from the tank, and then you know because then having 2 layers, right?
okay.
We have lots of room, right? Maybe
Sure,
move
sure.
up the that one stay at the top at the same level, right? Because that's
Uh-huh.
where the top flat bar is, right?
Yeah.
For true.
Flat
Yeah.
beam,
yeah, that's
right? And then just I
part of the
need
structure.
just one more, yeah, just in between, right?
Okay.
Yeah,
Below, yeah.
yeah,
Between
that'll
here.
be best for me. For
Yeah.
that truss, you know, the diagonal, you know, thing could be, you know, well, reduced
Oh,
or
just one
just
diagonal is
yeah,
enough
just
anyway.
one diagonal, yeah,
Yeah, because it's like an X bracing, and
right,
and you got all at the four corners.
yeah,
You've got diagonal, so it's
right,
braced in every direction
yeah,
basically
yeah,
to the wind.
Mm-hmm.
It's kind of three-dimensionally braced, which
yeah.
is
So Tim, you have to know, right, what I want.
Yeah. So was there any particular reason why you wanted to use like I-beam and channel, or would
Oh,
you consider
IB.
just using like a hollow aluminum tube?
yeah, a hollow aluminum tube. It's tube fastening is kind of fussy.
Yeah,
Tube fabricating even is kind of fussy. Because
that's right.
tubing has problem of being in alignment.
Right.
It can be rolling or
No,
rotate.
I was thinking square tube, not
Oh,
not
square
round.
tube. Oh yeah, a square tube is a real good option instead of a channel.
Well, it's just easier to get. That's all.
Okay.
Oh, easier. Okay. Well,
Well, I
then,
mean,
yeah, if it's a square tube,
The-
then the a joint, the junction, right? How you join them, you know, the junction, right? That would be different, yeah, design,
Yeah, there would be differences, but we could use brackets. Very
yeah,
simple
yeah, that's right. Sure. You
right
know,
angle bracket.
Tim, you know, just be creative, you know. You know, this is for my build, right? So this is not mass produced production, right? So,
Yeah,
once we get into mass production, then we can look at
yeah,
using different materials because we may have a longer time to source them, right? Rather
that's
than
right.
eggs.
Yeah, sure.
I think
Yeah,
it's done
Yeah,
pretty
just
quick.
use
So.
the easiest material, yeah, you can get.
yeah. Those are really good thoughts, Tim. We
So I'm gonna go to a couple suppliers
Okay.
okay.
today,
Yeah.
and I'll see what they have on the shelf. Maybe they have
Yeah.
some other ideas, and then I'll get back to you this afternoon with
Sure. Okay.
if any ideas change,
Mhm.
Okay,
and then
great.
Yeah.
um, Yeah, I think I've got all the information I need.
Okay, so you know
All right.
what are you doing, right? Good.
Yeah,
Yeah.
Well,
and
any questions, Tim? Any time on WhatsApp you have just a question, just
Right.
pop it in
Yeah. So
right there. We're at it,
no,
you know, going at it all the time.
yeah.
yeah, it's a good group.
Yeah.
I appreciate that setting it up.
Yeah.
Well,
Okay.
we're really happy, you know,
Yeah.
and amazing that, you know, your wife is so interested,
Yeah.
and building two is better than building one.
Yeah.
That's what we want, you know. We want this to go viral, you know, get everyone able to grow their own food really good,
Yeah.
really easy all year round.
Yeah, we are really interested for our place. Like, well, she wants to get into like obviously growing her own food, and
Yeah.
Yeah.
she loves her chickens.
Oh, you could have
Wow.
chicken.
Could be the
If you want,
chicken house.
you could have some fish and some chicken, whatever you want inside there.
Yeah,
Oh yeah.
yeah,
Oh
but
yeah.
we get on average about 6 eggs a day
Oh.
Sure.
from 4 chickens.
Yeah.
Okay.
Wow.
Fantastic. Well, your chickens will be very happy in this coop.
Yeah.
Very happy.
Especially summertime. In summertime, very cool. Wintertime,
Oh.
warm.
They'll be so happy.
Okay, guys. Well,
Sure.
if I have any questions, I'll
Yeah.
give you some messages.
Okay.
Send you messages.
Yeah.
I'll go
Nice
and
meeting
see
you
the
today. Yeah. Oh,
Yeah, you
don't
too.
forget to ask your wife to call me, okay?
Yes. Yeah.
Yeah. I need help on the website.
Oh,
She's she's pretty busy. She's dealing with a couple things.
I see.
Obviously,
Okay.
her dad passed
That's
away.
okay. That's okay. No,
Yeah.
no hurry. Yeah. Yeah.
But yeah, she'll get back. She'll get back to you this week.
Yeah. I work on I can work on most of the things. Just the style, right? I want better style.
Right.
Yeah.
Yeah. So,
Okay. Good.
well, she'll be in touch.
Yeah.
See you
Sure.
later.
Okay. See you. Bye.
See you.
Okay.
Okay. Well, you know, Tim just said he was going to use a countersunk
Yeah.
heads on the bolts.
Yeah.
It's a smart way to do it.
Yeah. You know. Well.
Then, you know,
Yeah.
they're flush, right?
Right. Yeah.
I love it. So we can do that.
Yeah.
So the other thing I was thinking about looking at, you know, is your footing design.
Okay.
And, you know, in some ways, this is a discussion maybe it'd be good to have Anthony involved in, because he's going to do
Right.
construction, right? Some
Yeah.
of the construction aspect. So let's assume that Tim is right about, you know, our first model, you know, prototype model,
Yeah.
can all be square tubing. Really, I think he's right. It's going to be easy to source it.
Mm.
And young, it's not that much change. I know it's like, and we will still probably use this design for the mass production, you know,
Yes.
Yeah.
because in some of the details, it's a little easier with the channel, you know,
Mhm.
reduces maybe some of the attachment, you know, issues and things, but you never know until you get into it, right? That's why I always was saying we're going to build it. We're going to have to reiterate, you know, and get engineers and the manufacturers. So Tim is almost like he's our manufacturer already. He's already suggesting things, right? Well,
Right.
we will expect that we want that.
Yeah.
You know, good manufacturers can
Mhm.
contribute the best details.
Yeah.
So, but now we have to look at our construction,
Yeah.
right? Because as soon as he's got this fabricated, we put it up, and that's construction details. And most important is, do we dig it into the ground?
Yeah. That's right.
Yeah.
Oh, also in the drawing we didn't show, you know, the thickness of the wall, right?
Oh yeah.
You see?
Yeah, we didn't show because
Yeah.
it depends
So
on how
actually
you built it.
Right. The
Yeah.
inside
Right.
should be smaller.
So now let's design the wall smaller. So what we do is just outside of the footing,
Yeah.
like about 6 inches or a foot even,
Yeah.
from the footing going outward towards the corner.
Yeah.
Or yeah, like we make a new square.
Yeah.
Yeah, that's expanded, right? We give it at least like a foot on all sides, bigger. Expand that square. Yeah, that's it. Yeah.
Yeah.
Okay. So that will be at the bottom of the 4-foot excavation.
Right.
That would be the new platform, right?
Yeah.
The soil, the flat area that we want to create.
There.
Yeah, that. And now we create sloping sides, right? Because the excavation
Yeah.
has to be, it can't be a straight wall.
Yeah.
Oh, and that's an image of the excavation that
Right.
we need.
Yeah.
And the slope goes all the way out to that, so like sloping out. Yeah, that's it. Yeah, like that. Okay. So, so we say, Anthony, this is what we're going to do. We're going to dig
Yeah.
this out. Now, if he doesn't need 20 by 20, fine. Maybe he only needs 15 by 15. It's up to him, right? We're just
Yeah.
giving him a guideline. But down below there in the ground, what we need there is we're going to need to excavate it like that and then compress the excavated surface, right? Compress it. Because, you have to put a footing on a solid ground, right? You know what I mean? You have to compress it, tamp it
Yeah.
after you excavate, right? Because you don't want just loose soil there. You want to pave it, right? And then what we could do is we could put some sand or gravel back, like a backfill.
Hmm.
Maybe I'm doing too much, maybe just compressing the soil will be fine. And then very carefully, we put those base plates in their position. It's kind of it's like doing any footing work, right? You need to accurately position your base plates, and we have holes right in the base plate. We can put pins to position them accurately, with a laser or with string measuring, placing those and so I have to make like a note about the excavation and the compressing, because when you compress, then we want to look at the most important thing is not only the location, right, but the
Yeah.
elevation.
Elevation.
That is now flat, right? It has to be that those are on the same plane, because if they're off, right,
Yeah.
of different height, that's
Yeah.
the problem.
Yeah.
We-
So,
we could-
Young, do you know what I'm talking about?
So you want to this like overhang?
Yeah, still have the overhand, but use the concrete, whatever, right? It's just they do, right? To just somehow just the same, yeah, the same thing, but we still build a thick wall, like at the board.
Yeah,
There's still,
don't change what you had. Actually, Young, what you had is fine.
yeah,
So here's what we do.
yeah,
The flat bar at the arches, the flat bar. What
Yeah.
we're going to do is extend it on a straight line,
Yeah.
like we do above in a way, right? When we get to the pyramid, we go straight, So we just continue to push it downward in the tangent on the same angle, so it's very nicely. Yeah, that's it. Straight line and
because
push it
it's not
downward.
much mass production, so
Yeah, push it downward like a foot,
yeah,
maybe about a foot of extension
yeah,
on that same tangent, So it's like a straight line.
yeah.
And it's just extending.
Keep going, yeah,
1 foot?
Keep going, yeah, 1 foot. And do that on each one.
yeah. And then that could create the cavity, yeah,
And that gives you your overhang to the eye,
right,
the visible eye,
Yeah.
right? Do you see what I'm saying?
yeah,
Gives you the same
yeah, yeah,
impression.
yeah. That's what I want, yeah,
Yeah. So what we do now is we extend the fabric outer skin
Yeah.
like an umbrella, right? And
Yeah.
it comes all the way down to that new extension. And it's just the outer sheet, right?
Right.
Because the inner sheet, of course, is still stopping as we've designed it before. So before we had a little bit of extension, now we've got a lot of extension,
That's right.
outer sheet.
Yeah. We can
And
simply
we could,
use the XPS board to do this, right?
yeah, but the sheet material is what you will see, and that's all really it's needed. It's
Yeah.
beautiful. And we can make it opaque.
Yeah.
The fabric can change to an opaque, like white or whatever
Right.
color,
Yeah.
and you'll see to the eye, you'll have that mushroom
Yes.
shape.
Yeah. Yeah. That's what I like. Yeah. Because then I can, if I need to collect the rainwater, I can build, the that system around it.
Well, the rainwater, I would prefer to let the rainwater fall on the ground
Okay.
and collect it at the ground.
Oh. Oh, yeah.
Huh.
Oh, that's a nice idea. Collect at the
Yeah.
at the ground. Yes.
Yes.
Yeah.
We're going to get into that. That's why I made the hole bigger around, right?
Ah.
It's 20
Yeah, that's neat. That's
because
neat. And
we're going to put a pond liner in the whole thing.
I could somehow feed that rainwater inside into the sand filter, and that's perfect, better than like the
So we don't come back to the inside here. No, we don't.
No?
It's just that outer sheet. That's it. That's it. It's just extended all the way around.
yeah.
It's like an umbrella. It's like the bottom of an umbrella. It's
Oh, yeah.
just the fabric material. It's just an extension.
Oh, okay.
Yeah. The wall we don't change. Use the same wall we had before, the thick wall.
Oh,
stick.
this is different idea then.
That's it. But to the eye, you're going to see this overhang still.
Right.
But you can't see through. This extension is going to be opaque,
Right.
right? So you can do an elevation view and you won't see.
Oh, this is nice. Yeah, this is
behind.
nice. And once I install the
There you go.
rain
That's
collection system, that's easier, right? The rain just fall into whatever, right? What do you call that? Trough? Yeah.
well, yeah. What I'm suggesting is that when we do that excavation,
Yeah.
we put a pond liner down in it.
Right.
So we have to go back and look at that excavation again.
Mm.
So let's look at it from the side. Yeah, that's it there. And
Yeah.
let's imagine that we do more excavation right under the building itself. So in other words, the slope that we have,
Yeah. More
we'll
room.
continue that slope underneath the building. Yeah, yeah. Even go more vertical, like in other words, even like it's a pit in the middle, in underneath the whole building. We excavate more, create a pit like maybe 4 feet deep. So it's like a block underneath here. Yeah, like that. And it won't have straight walls, but let's ignore that for now. And so now into all of this excavation, we put a pond liner.
Mm.
You know what I mean?
Yeah.
It's like a fitted pond liner.
Mm.
Maybe, it can be folded a little bit. Maybe it's one big sheet, but anyway, it goes in. And then what we do is we can backfill with gravel into that pit. So we put gravel into that pit, the one underneath the building.
I see what you're trying to do. Okay, you want to bring the water in from the bottom.
And the water goes into that pit, right?
Yeah.
So all
it's
the
like a
rain,
water tank.
it's a water tank underneath the building.
Wow.
Now,
That's good.
we'll need to put a sump in it.
Yeah.
with a sump pump, right?
Yeah.
Because we could flood our building. Because the water could continue to go in and go in, and our building is in the pit,
Yes.
so it could flood.
Yeah.
But if we at the same time we can collect water below the building, which is a good thing.
Yeah.
You
Yeah.
see, and all the rainwater and everything will continue to go there.
Yeah.
And if it gets to be overflowing, right? That
Yeah.
is to say, too high.
Yeah.
Then we can use our sump pump and just pump it out.
Yeah.
And we regulate that. So that's a possibility, of how this could be done. Because we can create this reservoir underneath the building, and it's very
Right.
useful.
Yeah. Very
It's
useful.
very
Yeah.
valuable.
Yeah. And increase
So
the thermal
done,
geothermal effect, right?
yeah, it's geothermal. Yes, it
Yes.
is. Yeah.
Wow.
So
This
we've
is the
got that.
easiest geothermal.
Yeah, and we could make it a little bit bigger, like we're resizing there,
Yeah.
and we can make the first part less deep. The wedge part, it could be like 2 feet, so we could expand the size of our
Yeah.
pool if we go upward, right?
Yeah.
Yeah, but also go upward, like
Yeah.
less deep in the ground is what I'm saying. Yeah, that the footings are only 2 feet below grade, right? And at 2 feet below grade, our hole is bigger, wider still. Yeah, that's it. That's it. So you see, without but bring the grade up, the bottom of the building, move it higher. The footing of the building goes up in the hole. Yeah, we're digging less deep to the. Yes, that's it. Move it up to the 2 foot deep elevation, 2 foot elevation in the hole. Now you see, you're not going to flood the building as you flood that. You see,
Yes.
you can bigger reservoir under
Yeah.
the building,
Yes.
and you're not flooding the building as you do it, right?
Yeah.
And the building is not as deep in the ground, but it's 2 feet deep, right?
Right.
So, and make that reservoir, expand it horizontally now. So you know what I mean, to the edge of the wedge.
So that reservoir always have water.
Yeah, the reservoir can be bigger, deeper. It's up to the design, right? It's it's one space, right?
But won't we
merge
have the
all-
problem like the other some mosquitoes, some
No, it won't have any of those problems because the water is underground. It's below ground.
oh right, it's below the dirt, right? Oh, I see your point. You
Yeah.
simply allow the water to seep in, right?
Not two separate tanks, okay? Merge all of that into just one. So you see now, Young, you've got like the.
So this is kind of a man-made underwater system, right?
Yes, it's a pool underneath the building.
Right. Okay. Good. So
yeah,
kind of
so
the
take-
water got filtered, right, through the soil or through the sand or gravel, and then into a basin
Yes, that's it. So
and got
let's
collected
look
there.
at it from the side, Young. Elevation view, side view. Yeah, that's it.
Ah,
You see now, it's one system. So you see the pond liner will come down the slope, right?
yeah,
And it's merging with the with the square. I say, like, just keep the outside surfaces, not in inner surface, just the outside surfaces.
okay,
The building is now sitting on the backfill of the gravel.
yeah,
Okay, so take away the inner cube that you have that the building's
Yeah,
sitting
yeah.
on. Let it sit in the air. Okay, don't put it
yeah.
on.
Lower
take
that,
that-
or just lower that.
Only keep the outer surfaces of that cube.
There, right?
Push it all the way down, Keep pushing it down.
Oh yeah,
I
yeah.
just
To the
I only
bottom.
want the outside. Yeah, just the outside surfaces, right? Yeah, no, there's no top to that.
That's right. Yeah, there.
All right.
Yeah,
Now
I see.
we-
I see. This is a big, big
And what
container.
we're doing is we're backfilling with gravel into this,
Yes.
right? first we put the pond liner,
Yeah.
then we backfill it with gravel,
Yeah.
and we compress the gravel, and that's where we put our footing.
Right.
So draw in like a gravel backfill, so
Yeah.
that the building's not sitting in the air, right?
Yeah. Yeah. That's right.
Because what it's sitting on is we dig first, and then we fill back in with gravel.
Yeah.
We put the pond liner,
Yeah.
and then we fill it back with gravel.
Right. Okay, that's neat. Oh, this is the best geothermal.
So we should have one drawing where we first do the excavation,
Right.
and then another drawing we put in the pond liner.
Pond liner, and then
Another drawing we backfill to the elevation
right.
of where we want the building.
Right.
And that's filling with gravel.
Right. Yes.
So you
Wow.
see the hole filled up with gravel.
Yeah.
So let's show some fill underneath the building.
Yeah. Use some gravel.
I don't know how you can do that, but let's say you fill up the hole.
Yeah.
With a material, which kind of representing like gravel.
Yeah. Up to there.
I don't know if you have some.
Yeah.
Yeah, up there. That's it.
Yeah.
And so yes, we've now filled in all of that part of the excavation. We still see the pond liner going up to the grade level. And now we're working inside the hole the same way, but now the hole is not so deep. Oh, beautiful.
Oh,
right.
Wow.
That's it. That's it.
Yes.
And how about you create a ground as well, so that we can see where the ground is, and make like a color like red for the liner, for the pond liner.
Ground.
I cannot make color to the line. So
Okay.
you want to see like here to
Yeah. Okay, maybe this is not important,
Yeah,
now,
but this is. I mean, as long as we know roughly what we're doing.
Yeah.
Yeah.
And yes, there will be pipes in there. There will be like drainage pipe.
Drainage
There
pipe.
will be a sump, a sump pump area.
Yeah. Right.
Because we work with this water, right? This
Right.
water
Right.
is
We need the water.
passively there.
Yes. Yeah. But
This
collecting
is part of our water thermal mass.
Yeah.
it go around?
Yeah, it would. Yeah, there would be like a circuit of piping in the ground, and it'll connect to a sump area, which is like a drum that we set into the gravel, right? A drum that's set in the gravel so that we can put a sump down there.
Mm.
And of course that drum will fill up with water, right?
Yeah.
Yeah.
Because it's really flooded. The drum will be flooded, but not our building.
Yeah.
And whenever the water comes up that might flood into the building,
Yeah.
well, there's two things we can do. We can put another water barrier so that our building
Or
is
there's another way,
protected.
or somehow the liner. See that the edge of the liner will be lower than the ground, the inside ground. Then then there will be overflow, right?
An overflow.
Yeah,
Yes, that's
overflow. Then it's outside.
True. Yeah,
So
overflow.
you always
Overflow.
have dry ground inside,
Yeah,
right?
right.
Yeah.
Yeah, and the kind of the scoop, right, of the pond liner
Yeah.
will collect all the rainwater that's falling in that area.
Yeah.
But the overflow will let it go out if it gets too high.
That's right. So the inside always stay dry,
Okay.
but there's some
Yeah.
moisture, right? Because you have wet,
But let's see the grade level, because right now, kind of hard for people to understand what we're really looking at.
Yeah.
So what we need to do, we need to extend that plane.
That's right. That's great.
And show sort of that we've excavated, so you have some kind of great ground,
Right.
what do you call it? Subsoil, right?
Mm-hmm.
Yeah, underneath the whole thing, and so we see that there's the subsoil, there's the excavation, the pond liner, the backfill. Then people just look at it and say, oh yeah, okay, I understand what you're doing.
Right.
You're digging a hole, you're putting a pond liner,
Yeah.
you're backfilling it with the gravel, and then you're putting your building on top of the backfill. And then at the end, you continue to backfill with the gravel.
Yeah.
Right?
Yeah,
up to the height,
that's right.
up
That's
to the
right.
height of the ground.
Mm-hmm.
So that now the building is anchored to the ground as well, right? When you backfill around it,
Yeah.
it won't tip over or anything,
No,
right?
no,
Because
it's
it's
very
it's like
yes.
it's plugged into the
Yeah,
ground,
plug into, yeah, buried into.
buried.
Yeah.
Yeah,
So
and I
the
like that.
door is
And then
over
of course
the
we need the
over the
stairway.
ground or over here. The
Maybe
door.
sand, use
Yeah, we
some
need the
sand or
stair
something.
going down. We need a stairway going down to the ground.
Oh, right, yeah. We need that too. The door entrance.
To the door.
Yeah, yeah.
We need
Ooh,
something.
where's the door? Oh, there.
It's over there.
Yeah, make it square, easy to build. But that's okay. This is, when we actually build it, we just use a squares thing. Yeah, just this is fine. Yeah, don't change this. Yeah. And then the steps. Ooh, boy, this is neat. We have this underground water. This is better than, and that's kind of a filter water. In a sense. So I could even use some sand, right? Gravel and sand. At the bottom gravel, then some sand at the upper layer, then because then the water gets some kind of filter, right? The leaves, whatever. Well, yeah, that's steps, yeah. Oh, this is nice. Neat, neat, neat. Wow, we collect the rainwater. This is the nicest way, easiest way to collect rainwater. Richard, I think this
Yeah.
is the easiest way to collect rainwater. I have never seen this something simpler than this.
Yeah, and you can choose to make it kind of a bigger collection area
Yeah, yeah,
just by making a bigger
yeah,
funnel.
and this is geothermal.
Yeah, it's geothermal. It's
Yeah,
really
because then
good.
yeah, sure.
All right, all right.
We
That I
can
like.
even
Well,
we can
yeah.
even bury the soap water, down. No?
Well, so now you see, this water is going to be your heat sink because
Yeah,
it's really
that's right. We
coupled
need a
to the
heat sink.
ground.
Yeah.
Yeah, the ground, is in close
Yes.
heat exchange,
Oh
right?
yeah.
And especially when you circulate and you're
Yeah.
deep enough that you're in a kind of ground
Yeah.
uh, like the ground is more wet, as you
Yes.
go deeper.
Wet. Yeah.
Oh, but then the tanks inside the building, which we still have tanks inside the building,
Yeah.
um, they can accumulate energy,
Yes. Yeah.
thermal energy.
Slowly. Yeah.
Yeah. So the plug underneath this water is basically a heat sink,
Mm-hmm.
but the tanks inside they can be warmer.
Yeah.
They're
What if
they're
I
like
bury
deep,
bury
yeah, to the extent
halfway?
that you bury,
Yeah.
because you can bury any kind of tanks in there,
Yeah.
and you can decouple them.
Yeah.
You can kind of have them more or less connecting
Yeah.
with the thermal mass below.
Yes. Yeah. Yeah.
Yeah, we're talking about tanks that could be coupled and decoupled. I know that's sort of a strange idea.
Mm.
Even this geothermal could be more strongly coupled or decoupled by having a barrier around, like a layer
Mm.
that's dry.
Mm.
So if you have a dry layer of gravel, it's
Yeah.
an insulator.
Yeah.
If you then flood that area, it
Yeah.
becomes a conductive layer.
Yeah. That's right.
So you have a dry layer or a conductive layer. So you
Yes.
can couple or decouple.
Right. Okay.
That's more in the ground, so that's more engineering
Mm-hmm.
of the geothermal
Mm-hmm.
design.
Yeah.
And the doorway is probably to the north.
Yeah.
But, it depends on your site, though, Aubrey.
On my
What
site,
do you think?
on my site, prefer uh, north. Well,
How would that work? Because it doesn't have to be, could be east-west. It's probably not south, though.
not south. No, it's
Yeah.
it's east.
Okay, so
Yeah,
east is
east.
good.
Yeah,
Well,
east.
east is a good place, yeah.
Yeah,
That's good feng shui.
yeah. Because then I can see from my window, right? See that door. Yeah.
Yep, yep.
In case
Okay.
someone or some.
Good.
Yeah.
Okay, that's really good. And you can remove the plane that's at the very bottom there. So kind of a line. Yeah, just don't even. Yeah, just kind of take the line away, kind of thing.
Yeah.
Or make it. Or if it's like if it's the subsoil, make it a little bit deeper. Then.
Yeah.
So
yeah.
showing that
the dirt underneath.
Yeah, that there's a subsoil underneath the excavation. Yeah. That just makes sense. Yeah.
Right.
There we go. Okay. Very good.
Yeah.
Very good. It actually goes to infinity. Yeah. In many ways. Yeah. That's the ground.
Yeah.
Oh, yeah. Okay. Well, this is what I thought would be a good thing to get today. Is to get through these thoughts about the construction.
Yeah. Yeah. Very good. So the liner actually stop at the junction between the vertical and the tapered area, right?
No, it's under the whole thing, right? So it's a pond.
Yeah, but it's below the inner ground, right? Because we don't want to see water. We want to when it's more water will overflow to the soil.
Yeah, we'll have that, like you said, a overflow.
Yeah, when we do the actual, we will figure out. Yeah.
Mm-hmm. But that is a container. It's really like a water container.
Yeah.
Of that, shape. It's a kind of geoengineering, right?
Yeah, that's right. Yeah.
Geothermal engineering.
Yes.
And the backfill is that you create porosity for water.
That's right.
And that the water moves easily, percolating.
Yeah.
In that geothermal device, right?
Yeah.
That's what it really is. It's a battery, right? It's our
battery.
water.
Yeah. Heat sink and heat battery. Yeah.
And a combination, water plus rocks.
Yes.
Is very effective.
Yes.
The rocks will hold the energy longer than water is very quick, to respond.
That's right. Yeah.
Rock have a delayed response.
Mm-hmm.
They'll tend to hold the heat energy in them.
Right.
But being that they're in water, it still is really effective to push heat in and out of the rocks.
Yes. Yeah.
One of the other ways people try to do this is with air, and air works very badly.
Yeah, air is badly. Yeah, it's hard to. Yeah. It's no capacity for heat.
Yeah. You just don't get the transfer of energy.
Yeah.
So
yeah.
Much better with a flooded bed like this.
Yes. Wow, this design, this is genius. I mean, this design worth the time today.
Yeah. And then, we're connecting a hydronic system
Yes.
of thermal energy storage, water
Yeah.
storage,
Right.
to our hydronic system
Yeah.
of distribution of that energy with the bubbles.
Mm-hmm.
So it's liquid to liquid, and it's very, very effective.
Mm.
There's no like air exchange. Most
Right.
systems looking for some kind of way of getting the heat into the air. We never try to do that, right? We're
No.
not trying to
No.
get this thermal energy into the air.
Yeah.
We just create a warm building envelope, the
Right.
roof and wall with the bubbles. That's what we
Yes.
control.
Right. We use bubbles yeah, bubbles because that you have the right intermediate state kind of a, right, air and
Yeah,
water. It's a mixture. It's not.
yeah,
Yeah.
yeah.
Yeah. Good.
And
Wow.
the the internal atmosphere, the internal temperature is going to be holding where we, would like to see it because all the surface temperatures are being controlled.
Right. Phew. This is neat. I like this. Wow, this is see this although it's very small, it has everything. Geothermal.
Yeah, yeah,
This is exactly what I'm looking for,
yeah,
right?
Yeah,
But yeah,
it's absolutely greenhouse.
yeah.
yeah,
It's a nice
wow, this is
experiment.
yeah. I sort of stopped stop contacting you because I thought geothermal works better. I focused on the geothermal, but I forgot
Mm,
about the other side.
mm,
Yeah, you
yeah,
you have this geothermal already. Yeah, but this way we expand, right, the capacity, right,
yeah, yeah.
increase the
That's it.
capacity.
Most of the projects I've done have this rock water bed
Oh,
underneath. Yeah,
oh, okay.
the Fairfield. You notice in some of the videos there, you'll see the
Fairfield.
gravel bed. In fact, you see them with wheelbarrows,
Oh, right.
building a
Yeah. I
gravel bed.
I wonder what they're doing, right?
Yeah, yeah, that's it.
Wow.
That's what's going on. They're building the gravel bed. The one
Ah.
I did in Montreal had that, and all have.
You see,
Sometimes,
this is something people normally don't see because it's underground.
yeah.
Yeah. Wonderful. Thank you.
All right, so I guess we'll leave it there for this morning,
Yeah.
Hmm.
and we'll get the feedback from Tim.
Yeah.
And then these drawings, which are really the construction site preparation,
Yeah.
you can share with Anthony
Yeah.
and get his
Yeah.
feedback.
Yeah.
And then because you could start the site preparation.
Yes. Yeah.
When how long will Tim take to fabricate the structure? Might not be that long.
Won't be long. I think he'll be
Yeah,
faster than the ground preparation.
yeah, that's it. So we can
Yeah.
start them at the same time even.
Yeah. I
Okay.
mean, now it's relatively warm. I think we can I think above sea air temperature is 1 degree. That's underground even warmer, 10 degree. So we can do some digging.
All right.
So this way, then it's 4 feet, 2 feet plus 4 feet, right? Looks like.
Yeah, 2 feet to the base of the
Yeah.
building and another 4 feet just for thermal
Yeah.
mass,
Yeah.
right?
Yeah.
Hmm.
Yeah. So I
Total
need
of
to order
60.
lots of gravel.
Mm-hmm.
Yeah,
Yeah,
gravel and sand. Some
yeah, yeah.
sand.
You can definitely have layers of sand as
Yeah,
well.
I would prefer to have sand on the top layer. Yeah, for the top layer.
Okay.
Yeah.
And if you put sand on top of gravel,
Yeah.
you can also use like a geothermal sheet, one of those ones that let the water through,
Okay.
but it'll hold the sand from just,
Mm. Yeah.
gradually,
Yeah.
gradually
Losing.
it's
Yeah.
gonna
Into the soil.
go,
Okay. Yeah.
yeah,
Okay. Sure.
yeah.
Okay. Good. Okay. Good.
And
Young.
probably don't put the sand in the backfill around the building, but not under the building.
Yes.
So in other words, building footing is standing on the gravel,
Right. Yeah, for
not
sure.
on a layer of sand, which can move.
Yeah, that's right, for sure. Yeah.
Gradually.
Yeah. Yeah.
Okay.
Just yeah, top surface, yeah.
Yeah.
Yeah. Around the building.
Yeah. So from where we have right now the gravel, you could put sand, and then above that you can put more gravel, and at the top, you could have planting beds. You could have,
planting bed. Yeah, sure.
you could have soil
Yeah.
on top.
Yeah. Yeah. North side, certainly I can, use that, to grow
Yeah.
something. Yeah. Right.
Yeah.
Looks nicer. Yeah.
Mm-hmm.
Okay. Good. Young.
All right.
Yeah. Thank you.
Young.
Yeah.
Appreciate it.
Oh,
Yeah, you can give me just this file, and then I can, I already recording this. Yeah, I'm recording this. I'll probably just explain just roughly, then using the yeah.
I like that view.
Whoa, that's yeah. Wow. This is Solar Geo. See, I have that website, Solar Geo.
Yeah, that's right.
Oh, wow.
And put that gravel surfacing all the way around those areas, then it'll look beautiful.
Yeah.
Ooh.
Showing.
Finally, I had my dream come true. Yeah.
There we go.
This is much easier. Oh boy. The GeoCube thing, that the more I study it, I find harder to do it. Because I have to bury pipes, going around and around,
Mm-hmm.
and a fan, right? But
what if you never get the?
Yeah, this is nice. This is passive. We call it passive geo. Passive geothermal.
Yeah,
right?
It's important, connecting the internal system to the heatsink external. So we're connected to the sky for energy and to the ground for heatsink.
Right. Yes.
Right.
Yeah.
And both of those connections should have, they can't be kind of like, our roof without the sun doesn't make any sense,
No.
So
totally.
our liquid thermal without connecting to the ground, right?
Yeah.
That's a necessity as well.
Yes. Yeah. Yes.
All right, gentlemen, I will say goodbye.
So one last question. Do I bury the containers? I mean, soap liquid container or not? Halfway or no need?
I would say that this is very experimental. That we can. Yes, you can definitely do that.
Buried is better than not buried. Give me more room.
To the extent that they're buried, they're more coupled to the ground temperature.
Right.
To the extent that they're not, they're on like inside the building.
Yeah.
Then you can run them kind of warmer.
Yes.
Because they won't lose.
I can even let the bottom touching the top layer of the water. Even.
That's right.
Yeah.
So and depending on where the water level is in this underground, if you bring it up, you'll create more connection to the tanks.
Right. Yeah. I mean, even
and
deeper.
If you let it go down, then you're getting dry gravel. So this is what I'm saying: is a layer of dry gravel is a completely different situation than wet.
Right. Yeah. So the bottom of the tank will be touching the wet gravel, right? But the top, is still dry, right? That way you automatically have that heat exchange.
Yeah,
that's
that's a sophisticated idea, right?
Yeah.
It's something that we were thinking about, that we could have layers of gravel that are able to be, you can withdraw the water and make them dry.
Yeah.
And then they become like a switch.
Yes.
connect or disconnect.
Yes. Yeah.
Well, that's more like geothermal engineering.
That's right.
concepts.
Yeah. So basically a sub tank, right?
Yep.
A sub tank to yeah, and there's
Or like a tank inside a tank, you
Yeah.
know, where you can put the intermediary.
Oh right, yeah, a tank inside a tank. Yes. And
Yeah,
then
it can either
you
be like
can easily right know when to do that, right? Easy control.
it's like a disconnect, you know, like when
Right.
we're dealing with air as a conductor.
Yeah.
So you can use a vacuum to completely separate.
Right.
And in a way, air is such an insulator compared to water
Yeah.
that if you have a dry airspace
Yeah.
compared to a wet flooded airspace, it's like a switch to decouple, couple or decouple thermally.
Good. Wow.
And then we have like liquid pumping to couple.
Right.
To couple heat exchange, you know. Well, a coil of like into our tank, we can have a flow of our cold water, and you know, water to water heat exchange. We turn the pump off and on to control that.
Yes, yes, that's a nice idea too. Yeah. Wow, that's wonderful. Yeah. Okay. Great.
All right.
Great. Thank you.
Yeah.
Okay.
Yeah.
See you later.
See you.
See you.
Bye bye.